Hey everyone, so today's video is going to be about the idea of polymerization. So polymerization is the process of making a long chain polymer by the repetitive arrangement of many small monomer molecules. So many small monomers are combining to give you a polymer. Like poly means many, mer means molecule, while in the case of monomer, mono means one essentially, like monogamy, monarch, and mer means molecule. So monomers are small molecules with smaller molecular mass, and they have the capacity to combine to make a polymer. While polymers have the same monomers, but now they are combined to give you a really long molecule, which is perhaps infinite. So we don't put an end to it, we rather put extended bonds from both sides, and we make small brackets and we write a small n in the corner to show a very large number of monomers. There are two kinds of polymers. One is the addition polymer, which we already have a video on and it was previously made, while there's another category called the condensation polymers. If you have watched the video on addition polymers, you would know that addition polymers are made when the monomers were alkenes, when the monomers had the carbon-carbon double bond where the addition reaction took place. But in the case of condensation polymers, the monomers do not need a carbon-carbon double bond. The monomer molecules are the ones which have various functional groups on them. Remember functional groups? The ones which were atoms or group of atoms on the organic compound, like the carboxylic acid one, the hydroxyl one in the alcohol, and there's another third one, the NH2, which is the amine functional group. So condensation polymerization is something that we're going to be talking about right now. Condensation polymers are made by the elimination of a small molecule, like water, like HCl, from the functional group of the monomers. Because the monomers don't have a carbon-carbon double bond, they can't do the addition reaction. So we snatch something out from the monomer so they can make new bonds. So the monomers need two functional groups in total, one on both sides of the monomer. So the monomers need at least one functional group, like the carboxylic acid one, COOH, or the alcohol one, the hydroxyl one, or the NH2, which is the amine functional group, on both sides of the molecule. You can't have it on one side. Like we have a 2 carbon, which double carboxylic acids on both sides. We have this second one which has the carboxylic acid on the left side but nothing on the right. And there's a third one which has OH on the left side and carboxylic acid on the right side. If we highlight the functional groups, we can notice that the first molecule has 2 functional groups. The central one has only 1. And then the third one has again 2 functional groups. So the first one and the third one can make polymers, but the middle one would not, because it can't make polymer from both sides right now, you see? Now imagine we have this 2 carbon carboxylic acid on the left side, which has double carboxylic acid, and there is a 2 carbon double alcohol on the right side with 2 hydroxyls. We always know that the acid lets go of the OH part and the alcohol lets go of the H part. They combine together to make the Ester linkage. The Ester linkage is being formed in the center right now. But if you notice, apart from the central Ester linkage, there's OH part on molecules right side and left side. So we have more possibility of esterification. There can be more Ester linkages made when the carboxylic acid part lets go of the OH and the alcoholic part lets go of the H. So from the OH and H combine to make water, and then these molecules join together to make even more Ester linkages and they combine with each other. There can be infinite reactions going on. That's why it's a polymer of the condensation polymerization, and it goes on for infinity. So we put a small n in the corner. It's a kind of a polyester, you know. Now identify the Ester linkages in the middle, and we can see that we can do multiple reactions like these. Like we have a molecule over here which has 2 carboxylic acids on both sides of the molecule, and we have this 2 carbon molecule again with 2 hydroxyl groups. Remember that the acidic parts and the alcoholic parts do condensation reaction. So the OHs are gone from the carboxylic acid functional group, and the H atoms are gone from the hydroxyl functional group. Let's copy everything else: the carbon double bonded oxygen, the bracket CH2, the 6 outside it, the carbon double bonded oxygen again. Not the OH, because you know the OH is gone obviously. Even for the other molecule, copy everything apart from the H, because the OH part lets go of the H atom. So copy everything else. And now connect them. You'll be able to connect the oxygen atom with the carbon, and you can make extended lines from both sides. Now put square brackets and put a small n in the corner to identify that yes, indeed, it's a continuation of many monomers. Let's have one more example where we have this molecule with hydroxyl group on the left side and carboxylic acid functional group on the right side. We can see that it is capable of making polymer, so we make 2 of this. Now what we do? We notice that the hydroxyl part lets go of the H and the carboxylic acid part lets go of the OH. We copy the remainders of the molecule, like the oxygen, the 2 carbons, the hydrogens from the top and the bottom, the 3rd carbon with the carboxylic acid. We copy the same structure on the right side because it's the same monomer being repeated. So again, 2 carbons with the H's on the top and the bottom, the 3rd carbon with its carbon double bonded oxygen, but the OH is gone obviously. So you connect them because they have the capacity of connection, and you make extended bonds from both sides of the molecule. Then you put a small n, and there's ester linkage in the center. So it's kind of a polyester because it has many ester linkages, and this is how condensation polymerization works. I really hope that in the coming video we'll talk more about this and we'll see how it can make multiple kinds of polymers. So stay tuned guys. Thanks.